Play his flute during the intro, man. We are live now.
Oh, all good. You know, once when a man's in the middle of a flute solo, you don't interrupt a thing like that.
No, he's
Learned that from
harnessing
Ron
and
Burgundy.
manipulating. Yep.
Hey, everybody, welcome to Reading Night here at Aether Cosmology. This is Reading Night numero 25. So it's not even including the few bringing your own Brenner comps and other random one-off reading nights where we just, can't help ourselves and just had to, have a fun time and jump into a couple of papers. Well, yeah, 25 of these. Pretty fun. Let's go on now, or 24 so far. Let's get into, tonight we're going to get into, or hold on. Sorry, I'm getting a little ahead of myself. I got to throw the disclaimer out there that I do every one of these, just to let you know that this is literally reading and research night. We literally read papers, we read books, and, if we have a question, we have a thought, something we want to look up in the middle of that, then we will do so. So it's not always necessarily the most entertaining thing, but if you want to come read with us, you can join us at discord.gg/ethercosmology, or maybe more easily, just go to ethercosmology.com, click on the little Discord icon, and you can join the server there. And you can come read with us. We do this every Monday night at 9 p.m. Eastern. And without further ado, let's hop into some Demjanov. And I guess I'll go ahead and kick us off here. So tonight we're going to read, this is the first paper we're going to read. Wait, did I open the wrong one? Or no, this is the right one. Yeah. The date caught me off guard. I thought it was 2001. Oh, the first paper. Okay. This is like a corrected version. Is that right? All right, well, I guess we'll find out. So yeah, Michelson interferometer operating at effects of first order with respect to velocity over the speed of light. Third method of measuring the speed of ether wind by V.V.Demjanov from UshakovStateMaritimeAcademy in Novorossyisk, Russia. Novorossyisk. In the first version of this paper, there is a described first traditional method of measuring the non-zero shift of interference fringe in the Michelson interferometer, operating on the effects of the second order with respect to velocity over the speed of light, and are revealed hidden causes of the failure to measure the shift of interference fringe in the period from 1881 till 1960. It is shown that at the latitude of Abinsk, within a 24-hour observation period, the horizontal projection of ether wind velocity varies from 100 kilometers per second to 480 kilometers per second. The second version of this paper is supplemented. I'm assuming that's the one we're reading, right?
We're reading whatever the finalized version is.
Well, so this has to be the second,
other,
because they wouldn't know there's a second one in the first one, right?
Unless there's a third. That's, I guess, kind of the question, right? But in any case,
right.
Where was I? The second version of this paper is supplemented with a second method of finding the velocity of the ether wind. Though through measuring the largest seasonal decrease in the ratio of the summer shift of the interference fringe to the winter one, equaled at around 12%, it gave the same interval of values of the projections of the ether wind velocity as the first method. Below, the third method of measuring the ether wind is described that appears to be in agreement with the first two methods. More than 100 years there persists a belief that the Michelson-type interferometer cannot be adjusted as to detect effects of the first order with respect to velocity ratio to the speed of light. Below, I show that it is possible to measure the interference fringe shift, and thus the ether wind, on the first order Michelson interferometer, and more successfully than on the interferometer of the second order. In contrast to the traditional approach, in the interferometer of the second order, the light, after splitting on a semi-transparent plate, propagates in both arms to the reflecting mirrors in one optical medium within dielectric permittivity of epsilon 1 and returns after reflection from the mirrors through another optical medium with dielectric permittivity epsilon 2. The shift of the interference fringe is reliably detected in the experiment when turning the interferometer by 90 degrees. It was found to be proportional to epsilon 1 minus epsilon 2. Experimental data are interpreted in the bounds of the Fresnel drag of light by moving optical medium, neglecting terms quadratic in velocity ratio to the speed of light. The horizontal projection v of the Earth's velocity relative to luminiferous ether thus found lies in the range of around 400 kilometers per second, greater than the velocity greater than 480 kilometers per second.
That's actually between 140 and 480 kilometers
Oh,
per
thank
second.
you. Thank you. Yeah, that's okay. So within the range, the velocity within the range of 400 kilometers per second to 480 kilometers per second, depending on the time of the day and the night at the latitude of Abinsk. This is the third method of measuring the speed of ether wind. It gives the same range of values as two earlier described methods, operating at the second order with respect to V over C. Two variants of ether wind's detector. As it is known in citations 1 and 2, there is no fringe shift in evacuated Michelson interferometer. Thus, the mode of the device is not fit to detect quote-unquote ether wind. Michelson interferometer becomes sensitive to ether wind when using it as a light's carrier in optical medium with a refractive index of n greater than 1, as shown in citations 1 and 2. If light passes always in a single medium, the interference fringe shift xm appears to be proportional to square of the velocity v of the interferometer relative to ether. xm is approximately equal to v over c squared, where v is approximately less than c. Is that correct?
That's actually much less than c.
Much less than c. Okay, thank you. Much less than, okay. So the velocity v of the interferometer relative to ether xm is approximately equal to v over c, where v is much less than c. Okay, here the allowance for Lorentz contraction of the interferometer's longitudinal arm is vital. Below, I report results of the experiment on Michelson interferometer configured in such a way that light runs consecutively via two optical media. It goes at first through one medium and then returns back through other medium. In this case, the fringe shift proves to be proportional to velocity over the speed of light, where velocity is much less than the speed of light. So the two media mode device is sensible to ether wind. Besides, in the interferometer of the first order, the contribution of relativistic factor into the fringe shift, being quadratic with respect to v over c, can be neglected as small quantity. Huh, so a fun way to look at it. The device in question is a common rotary cross-like interferometer, as shown in figure 1. So here we go. EV camera. So this is your detector. Must be source.
It's kind of like two loops to a figure 8. One of them is sent upward, and the other one is sent to the right.
So this is source here, right? That's what I'm trying to figure out. This must be source.
Yeah, that is the source.
And then we
they're
go
receiving
boom.
at 1, 2, and 3 below center.
Where we go. Boom, and then we go boom. Okay.
So one reflects off that first mirror, and one refracts through it.
Yeah. Gotcha. Very interesting. Okay. Coordinate recorder. Okay. I'm just going to read the figure thing real quick here. Functional scheme of the first order by velocity over speed of light interferometer from 1971. Light issuing from the source S splits at the semi-transparent plate and goes consecutively through two glass tubes filled with the light's carriers of respective dielectric permittivity, epsilon 1 and epsilon 2. Ends of the tubes are covered by thin glass lids. After reflecting from rebounding mirrors, the light returns for interference at the other half-transparent plate. 1 is the interference screen. 2, telescopic ocular. 3, Vidicon with a deflecting facility. 4 and 5 are feeding and video cords passing via the tube 6 in the center of rotation. 8 is the interference pattern at the screen of the kinescope 7. All right, cool. Light firstly splits by the half-transparent plate into 2 orthogonal beams. Further, each beam goes to rebounding mirrors through the optical medium having dielectric permittivity epsilon 1, and then returns in the medium having dielectric permittivity epsilon 2. Media are separated in space by minor displacement of return containers. The respective shear of light's beams is secured by means of 2 mirrors. Thus, returning rays meet in the point laying at another semi-transparent plate that is angled at 45 degrees just as the splitting plate. The space separation from the incoming beam of the light outgoing to the interference screen, 1 on figure 1, brings down parasitic noise as compared with the usual construction of the second-order interferometer. Next, collected on the plate, figure 1, rays are projected by the telescopic objective 2 on the screen of the Vidicon 3, and then transmitted by the TV camera on the screen of the kinescope 7. Computing ether wind velocity from interference fringe shift. The interference fringe shift is proportional to the difference, delta t, of round-trip times according to xm equals the speed of light times x0 over lambda times delta t, where x0 is the bandwidth and lambda the wavelength. By virtue of citation 1, we may reason in terms with intervals t. The speed of light, c, in the moving, or I guess approximately c, in the moving with velocity v greater than 0 optical medium is given by the Fresnel formula, formula 2 there. As measured in the reference frame of the moving medium, here n is the refractive index, and delta epsilon equals n squared minus 1, the contribution of particles into the dielectric permittivity epsilon equals n squared of the optical medium. From citation 2, we have for the round trip time t in the direction of the interferometer arm parallel to v. So the t variable there equals your nice little equation number 3 here, where epsilon 1 is the dielectric permittivity of the forward medium and epsilon 2 that of the return medium. In deriving equation 3, I was saying citation earlier, but these are referring to the equations. In deriving equation 3 with terms the velocity over the speed of light squared were discarded. We have, for the round trip time in the orthogonal direction, equation 4, where again, terms with velocity ratio to the speed of light squared were neglected. Subtracting equation 3 from equation 4 gives equation 5, which is showing for delta t. Formula 5 shows that the difference of round-trip times depends on the difference of the contribution of particles into dielectric permittivities of 2 light-carrying media. Section 4, measuring interference fringe shift. Figure 2 shows the measured amplitude AM of the harmonic component of the interference fringe shift as a function of local time t local at the attitude of Obninsk. Measurements were covered 24 hours of the day and night. The light's carriers were in the forward direction carbon bisulfide, delta epsilon 1 equaling 0.0036, and on the return path, the air at normal pressure, delta epsilon 1 equaling 0.0006. The right scale of ordinates shows the values of the ether wind velocity, v Hor, approximately equal to, or yeah, approximately am kilometers per second. The dependent velocity of t local agrees well with that obtained on the interferometer of the second order with respect to the velocity ratio to the speed of light. According to equation 5, the first order device is the velocity over the speed of light minus to the power of -1, which is approximately equal to 1,000 times more sensitive than the interferometer of the second order with respect to velocity ratio to the speed of light. This enabled me to use a relatively small arms with a length of only 0.2 meters. Interesting. Figure 2 shows measured relative amplitude AM equals XM over X0 at various times of day and night. Local time at Obninsk, 55.8 degrees north latitude, on the 22nd of June, 1971, where XM is the amplitude of frequency fringe shift and X0 equals 90 millimeters is the bandwidth of the kinescope's screen. Light carriers are CS2 having epsilon of approximately 0.0036 and air having epsilon of approximately 0.0006. The line width shows the jitter noise A sub ns of the interferometer. The horizontal projection V hor of the ether wind velocity computed from A sub m by equation 5 with equation 1 is shown at the right ordinate axis. Parameters of the experiment arms are L1 equals L2 equals 0.2 meters. Wavelength lambda equals 6 times 10 to the -7 meters.
So this is the 140 to 480 on the right scale, the velocity scale.
Oh yeah, yep.
Min to max, yeah.
And then here we're looking at local time. Okay. Wow. Looks kind of familiar, not gonna lie.
Little daily fluctuation, if you will.
Yeah.
It does look pretty Miller-esque.
Yeah, and Galev. All right, so
Dude, speaking of Miller-esque, fantastic graph you made, Stone.
Oh, well, thank you.
I'll take a quick drink of water here. So, figure 3, I'm going to zoom out a little bit here. Figure 3 shows the dependence of the interference fringe shift on the difference epsilon 1 minus epsilon 2 between dielectric permittivities of light carriers. As we see, XM linearly grows from epsilon 1 with the difference to epsilon 2 equaling 0 to the difference of epsilon 1 and epsilon 2 equaling 1. By equation 5, the sensitivity can be enhanced in 10 to the 5 times, 100 times due to epsilon 1 minus epsilon 2, and 1,000 times due to the velocity ratio to the speed of light, so that the measuring can be performed at microwaves, i.e. 10 to the 5th times greater wavelengths than in optics. The microwave experiment was made using the Casio ferroelectric guide, epsilon equaling 255 at lambda equaling 10 centimeters, by the direct measurement of the phase difference. The converted to...
I think that's...
Yeah?
I'm sorry, go ahead.
No, go ahead. If you were going to make a correction, please.
No, finish the sentence, and I'll add.
The converted to XM magnitude lies exactly on the continuation of line 1 in figure 3.
So yeah, that I think is calcium titanium oxide ferroelectric guide.
Thank you.
As far as the element breakdown there. And just above that, 10 to 5, of course, that is 100,000 times. 100 times due to this and 1,000 times due to that equals 100,000.
Oh, yeah. Thank you,
Yeah,
sir.
maybe.
So that was discussing figure 3, and then here's some more info on figure 3 here. Measured shift of xm in the interference fringe as a function of the difference between epsilon 1 and epsilon 2 between dielectric permittivities of the two light carriers. So red 1 air, epsilon 1 being 1.0006, ratio to the lab vacuum, and then epsilon 2 equaling 1.000006, and then CS2 1.0036, and then your red 3 would be around 2, and then and ordinate scales are logarithmic. Line 1 corresponds to xm max. Line 2 to xm min in notations of the figure 2, with phi x ns is the jitter noise read on the screen of kinescope. Parameters of the experiment for CS2 arms are L1 equals L2 equaling 0.2 meters wavelength, lambda equals 6 times 10 to the negative 7 meters. All other data are reduced to this values. All right. Oh, so we're into the conclusion already. Thus, the reality of the first order with respect to velocity ratio to the speed of light Michelson interferometer is experimentally demonstrated. Experiments show that the shift of the interference fringe occurs in optical media and is absent in vacuum. The first order interferometer is velocity ratio to the speed of light to the power of -1, approximately 1,000 times more sensitive to ether wind than the second order Michelson interferometer. The first order interferometer shows the ratio to the ratio signal to noise being approximately 100 all around the clock. Such the resolving power and stability of measurements at any time of day and night in any season attests confidently the presence of the absolute reference frame with the Earth moving relative to it with the velocity that is above 480 kilometers per second. Earlier, the same estimation of the ether wind velocity has been obtained on Michelson interferometry by two methods, shown in citation 3, operating at second order effects with respect to the velocity ratio to the speed of light in citation 2. It was historically the first method that took into account parameters of optical medium specifically used as a light's carrier. The content presented here is actually a third method of experimental measuring of the velocity of quote-unquote ether wind via the shift of interference fringe and the transverse beams interferometer. The method operating at first order effects with respect to velocity of the with respect to the ratio of velocity and the speed of light due to the use of two optical media as light's carriers. Thus, kinetic evidence for existence of luminiferous ether are to this time provided by three-phase interferometry techniques, two operating at second-order effects, and the third one described in the present report at the first order one. So boom, there we go. That was 2001. Big year for ether. I think the first one was from 2001, right?
OG one was, yeah.
But does he believe the Earth is flat, guys? That's really what it matters. So that's really listed papers. They were like, yeah, but they don't say it's flat. And then I put an ether wind paper. They were like, it doesn't even say rotation. I was like, did you control F rotation? Yeah, that's not gonna work.
So yeah, pretty interesting take. Yeah.
And the good doctor has snuck into the room while you were reading.
Yeah,
Gotta
I
be
saw
sneaky.
that. If anyone has any thoughts or questions on the content of that paper, please feel free to share.
What's up, boys?
Yeah, what's up, Yezo?
Yeah.
Reading some Demjanov.
Demjanov. Hold on, I'm trying to remember which one that is. Hold on, Demjanov.
This is a new lad. We haven't really read into him.
But I've
He's,
been using his data now. It's on all of my database.
Wasn't he a light guy? Like, didn't he do something with light?
Yes. Michelson-Morley style interferometers.
Word.
It's a pretty good guess around here.
Oh, Rock, you know, hit some interferometry.
Let's see here. I'm gonna guess he did something with light and Sanyak.
Oh,
Maybe
speaking
ether?
of interferometers, Toby, I tagged you in that picture. The Stone graphed out the plots from Miller's data, kind of show what the curves would look like for the periodicity measurements. It's a very nice, clean, modern rendition.
Yeah, it was a cute little trip.
Yeah.
Very interesting.
Yeah, we put together each sample, and there are 20 of them over that 40-minute period of time. At 3 in the morning, we just put them into a stacked series so that you can pull the trend out visually, and I think it stands out pretty well.
Yeah,
I agree.
nice. All right. So, without further ado, maybe we should hop into this next one.
The old physical interpretation of the Fringe shift measured on the Michelson interferometer in optical media by V.V.Demjanov. Shift delta XM on the interference fringe on the Michelson interferometer is absent when the arms light carriers are vacuum n equals 1, but present when the measurements of the refractive when the refractive index n of light is carrying n less than 1. No, n greater than 1. The experimental observation induced me to interpret the physical process occurred in the Michelson interferometer in a conceptually new way. I rejected the classical rule of C prime equals C plus or minus nu, of adding velocity nu on an inertial source of the interferometer with the velocity of C of the light emitted by it as incapable of the principle to the non-inertial object with electromagnetic waves just belong to and not taking into account n of the optical media, so the refractive index of the optical media. I used instead of this rule the non-relativistic formula of Fresnel drag of C over n plus or minus nu 1 minus 1 over n squared. The speed of light in a moving optical media. Dude, non-relativistic, you don't say. Dude, so funny. Some of the arguments we get into. You start having flashbacks when you just read something that's super coherent and clear. Anyway, where n is taken into account with the condition C prime is greater than C always holds. This formula is accounting for the physical effect of Lorentz contraction of the longitudinal arm, L brackets of the interferometer.
That's
because
the full
its
length
motion.
return trip.
Okay, thank you, sir. The full length return trip of the interferometer, because of its motion in a stationary ether, enabled me to construct a theoretical model of delta XM approximately equal to that length trip delta epsilon 1 minus delta epsilon, where delta epsilon equals n squared minus 1, and its contribution of the particles to the permittivity of the light carriers that reproduced in the essential features of the parabolic dependence of delta XM on delta epsilon. From the experimentally measured amplitudes of the shift in the interference fringes, there was estimated the horizontal projection of the velocity of Earth relative to the ether that changes at different times of day and night at the latitude of Obelisk within the limits of 140 divided by
I think that should be a
180.
dash, 140 to 480. It should be
Like
a
a
dash,
range
according to the graphs we were
yeah.
just looking at.
Yeah,
it
that's
even
what I was
says
thinking of.
limits. Yeah.
Yeah. All right. So within a range of 140 to 480 kilometers a second. Fourth version of the report is complemented with an account of the harmful effect of registering the shifts of delta XM of the interference fringe of the improperly installed and the turning points of the zigzag light path of the glass mirrors. The nullifying of the shifts of the air interferometers may occur because the opposite signs of the contributions of the air and the glass optical media through the discovered by me law of delta XM approximately equal to the length delta epsilon minus 1 delta epsilon. This is because of the cause attaining the negative effects of the majority of the Michelson type experiments known to date. All right. The Michelson experiment and its standard interpretation. By definition, the ether is a hypothetical media that serves to carry over electromagnetic waves and to transit the interactions. Supposedly, the Earth moves through the luminiferous ether at a velocity of v, and in order to detect this motion experimentally, Michelson measured the time needed for light to cover the distance L from the light source to the rebounding mirror back and forth in the directions of the total length, or the time of the total there and back trip, minus in the arm parallel to V and T perpendicular to that, minus the arm perpendicular to V. Let's see. The experimental data obtained were interpreted by him in the following way. He considered it to be sufficient to determine the light's time, or the time of the light's propagation and the longitudinal arm of the length for the full trip forth by the velocity of c plus v and back by the velocity of c minus v, or nu, but velocity. In the form not taking into account the refractive index of the optical media given by equation 1, where we're going to throw an n in there somewhere, I'm sure, to account for the media there or whatever.
Nay.
Anyway, yeah, not seeing any n's, are we? Yeah, well, maybe. See, the time that light would spread on the transverse arm, accounting for the lens contraction of the motion of the beam along the hypotenuse of the triangle, is usually written by equation 2. And for the case of questioning measuring the difference of the times 1 and 2, or the there and back trip are equal to the length perpendicular to the, which is equal to the regular length, given by equation thrice. We would find that the speed nu of the ether wind, Michelson used Maxwell's idea to determine the delta t by measuring the amplitude of the shift delta xm of the interference fringe in the superposition of the beam at the interference screen. The amplitude of the shift xm is related to the delta t by the proportion given by equation 4, which is delta xm is equal to cx naught delta t over lambda, where x naught is the width of the interference fringe and the lambda is the wavelength of the light ray of the interferometer. However, measurements of Michelson and the later experiments show that the value of the delta xm equals to a null. This fact has been explained in the bounds of physics by the Lorentz-Fitzgerald contraction longitudinal to v of the length of the return trip, of the total return trip, of the value of the moving body with a velocity of nu, given by equation 5, where the full path length is the length of the longitudinal arm of the moving interferometer. In this model, the length perpendicular was taken to be independent with velocity.
I take it back. He might be differentiating between the longitudinal, parallel length and the perpendicular length. That there's array part 1 and array part 2. Do you remember that? Right after the first.
Oh, so
split.
Parallel and then perpendicular.
Yeah, he's just saying that the two
Gotcha.
paths are the same length. That's what he's talking about there. I'm sorry.
All G. With the parallel length of the longitudinal arm of the moving interferometer, yeah, and then this is the model, and the length of the perpendicular is taken to be independent of v, yeah. With a count to 5, and we obtain instead 1 given by equation 6, and from 6 and 2 we have the exact quality of the time parallel is equal to the time perpendicular, which is i.e. the delta t is 0. There's no change in the old path link there. See, the Michelson experiment in the optical media and its new relativistic interpretation. In 1968 to 1974, being a scientific researcher at the Obelisk branch at the Karpov Institute of Physical Chemistry, and in experimenting with the Michelson interferometer, I detected an occurrence of a non-vanishing amplitude of a shift delta xm not equaling 0 of the interference fringe in normal air, and enhanced the pressure continually vanished in the course of the evacuation of air from the light carrying regions of the interferometer. I measured delta T for the various transparent dielectric materials with the optical dielectric permeativity of 0 being greater than epsilon, or what was that, the range? So the range would be 0 to 3.5 epsilon.
Quite correct.
Epsilon, that I have managed to recently and briefly publish. Figure 1 presents a more detailed experimental data comparing with those that I have given in the e-prints of the archive here, and then see version 2. The necessity to refine them, the renormalization to a common parameter, the length L of the arms, the wavelength delta, in a single time of day or night of implementing the measurements, was pointed out to me by the referees of the manuscript of the article in the Journal of the Physical Letters A, given by citation 4. I thoroughly performed such renormalizations in figure 1, citation 4, after which the article was accepted for publication in the PLA, and so I present below the figures from the PLA in a more elaborate form as figure 1, supplementing it by the curve 2 with a little more detailed description of it. Because of the brevity of the previous description of my experimental results, I present below table 1 containing the full primary, non-normalized but directly read off the screen of the kinescope values of the measured amplitude of the harmonic shifts of delta xm of the interference fringe. This data was obtained at 3 different frequencies. Frequencies of the rays that provided me with a region of the normal dispersion with 6 different values of the dielectric permeativity of the light carriers. 3 at water, points 1, 2, and 3, and 3 with fused quartz, points 4, 5, and 6, and 7 with points *7. I obtained at glass, quote, heavy flint, at the most permeable at the most high permeable in my experiments. In comparison to figure 1 of article 4, figure 1 given is supplemented by the curve 2 corresponding to the minimal values of the amplitude of the shift of the interferometer fringe in the 24-hour cycle of the day and night, observing the value x or delta x m minimum obtained at the mentioned 7 permeativities of light carrying media by my interferometer. Let's see. The first of my discoveries has been of the pumping of air from the region of light carrying space in both arms of the interferometer, i.e. evacuating the light carrying space, turned entirely to a null of the amplitude of the harmonic shift of the interference fringe, making the delta xm equal 0. The restoration of normal air pressure in the regions of the light carrying space recovered the non-zeroth value of the amplitude of the harmonic shift of the interference, making the the delta xm greater than 0, in which the connection of the increase of the air pressure in light carrying envelopes brought forward to growth of the delta xm. For the instance, at the air pressure or at the pressure 2 atmosphere, the value delta xm rebounded in comparison with the normal air pressure. See table 1. In table 1, I present also the data measuring of delta xm epsilon performed for gaseous light carriers covering the interval of the permeativities of 1.003 greater than epsilon, or the range from 0.003 to 0.037. It is impossible to show that this data at the linear scale of this axis of delta epsilon. Figure 1, and so there was shown to be in it conditionally only the point of air. Air, is that it's supposed to be denoting something? How would you pronounce that other than just saying
Point
air?
sub air.
Point sub air. Okay, thank you, sir. Point sub air. Yeah. Okay. For the normal air pressure in the order that the reader can see the low quality of the experimental measurements on the Michelson interferometer and the air environs, which were obtained before me up to 1968, since all of them were situated lower at a point sub air, and were drowning in the ether, Toby. We're drowned in the noise. The full data. The full data from.
Let me just get this. Let me just like pause on this for just a split second, so anyone that wants to look at it on the stream can do a little pause and.
Yeah, can we get up to the graph there? That'd be cool.
This you're talking about this one here, right?
That's the one. Yeah, look at that shit. It's quite the split.
Yeah. Indeed. And then if you wanted to read this as well, but I mean, I'm not saying we'll read this right at the moment, but if anyone on the stream wants the details on the graph, there you go. But yeah, so and we're drowned in boom.
Noise. The full data from table 1 in the form plots a double logarithmic scale of the axis delta xm and delta epsilon were published by me in citation 7. In figure 1, it is shown, there is shown by me, in figure 1, there is shown found by me parabolic dependence of the amplitude of the fringe delta xm times delta epsilon on the part of delta epsilon equals epsilon minus 1 of the full dielectric permeativity epsilon of the optical media, excluding the contributions of the polarization of the vacuum, equals 1. As we can see from figure 1, the output ratio of the signal to noise is improved considerably for the media with a refractive index of n being greater than 1, where n equals the square of epsilon of that of air, or than that of air. Second. Observing in my experiments the dependence of the interference fringes on the dielectric permeativity of the light carriers in the interference interferometers, I have come to the end, to above describe the analysis of the dispersion properties of light of the carrier medium. In order to explain the run of the experimental curve delta xm of delta epsilon, shown in figure 1, I rejected the inadequate rule of the composition c plus or minus nu, or velocity, with the speed of light and the velocity of nu for the translatory motion of the optical media that was used in the Michelson in deriving the relations. Although the Maxwell-Selmier formula has already been known in 1881, Michelson was not able to make use of it. The more they cannot know, then the more that he can not know, then that the classical addition of the velocities c plus nu is not valid on his device, not to mention the natural ignorance of the effect of the Lorentz contraction of the longitudinal arm of the interferometer. In the end of the 1960s, when I performed the measurements of the modernized Michelson interferometers, the relativistic law c over n, Earth's velocity equals c prime, where, no, is that not the symbol for Earth? I don't know. Where the
it's a relativistic factor.
Oh, gotcha. Okay, where this operator operates a relativistic addition.
Yo, sorry, my thumb hit the page number.
You're straight. You're straight. I gotta reset the crabs anyway. All right, we're good. All right, let's see. Where were we at here? Okay, yes. Thank you, sir. Where the circle with the cross is the operator for the relativistic addition for velocities in the condition c prime being greater than c, where were already known and described in physical textbooks. And I use the Fresnel formula for the dependence of the light speed on the parameters of the moving optical media, by which the speed of light C prime in the media never exceeds the speed of
Light C and ether without particles.
Yep. What he said, and then given by equation 1, where we have C plus or minus equals C over N plus or minus nu, 1 minus N over N, or 1 over N squared. Following the line, we will instead use equation 1 with the reference frame of a stationary ether given by equation 8, where C sub plus and C sub minus are the values for equation 7 for the propagation of the light carriers along V and in the opposite direction, respectively. Detecting and measuring of the interference of the fringes is performed by using a tool situated in the movable Earth's reference frame. Therefore, passing in equation 8 to this reference frame, it is necessary to make the correction on the effect of Lorentz contraction of the length of the moving body. You just gotta make sure you always correct for that first, right off the rip, obviously. Let's see. For the case of the equation where we suppose that beyond the light source of the mirrors of the interferometer, that light propagates mostly in a stationary ether perturbated by movable particles of a light carrier. It is here where all the time of the delay of the parallel, or of the time parallel of the propagation of the arm of the parallel length is accumulated, that further is registered in the measurements of the interference fringe shift performed in the movable laboratory reference frame and recording plate of the device. And in so passing from the ether to the Earth's laboratory reference frame, the experimental setup should be taken into account for the Lorentz contraction of the longitudinally movable arm L of the interferometer given by equation 9. Substituting 9 with the respective values of equations 7 and 8, we obtain the direction parallel to the velocity given by equation 10. I'm just going to hop out of the lab frame real quick and contract my apparatus.
Much better. All contracted now. Back to a constant speed of light.
Yep. Let's see, where delta n squared equals n squared minus 1. In the transverse arm, light propagates perpendicular to the direction of motion of the light carriers. In this case, from equation 2 with the account from equation 7, we obtain the time delay t perpendicular of the ray. Time perpendicular of the ray in the transverse. Let's see, in the transverse to the velocity direction of the length of the arm, length perpendicular equals L does not.
Testing 1, 2, 3. Testing.
Yo, what's up?
We got you, Rob.
There he is, loud and clear.
Okay, it finally got through.
Nice. What's up? You got some input?
Yeah, I came in late, and then I've been struggling to solve the voice problem, which it turns out you need. It's two modes: voice activation and push to talk. Apparently, I was in push to talk and didn't know it.
Ah, yeah, that'll get you.
Oh.
That's a classic.
I've been following for about 10 minutes, and I'm really sorry that I missed like most of this. I know that you already did one paper. I guess let me just listen to the rest of this and then maybe circle back and hit
Good
the
plan.
highlights.
Sounds good.
Because I've read the papers before, not in detail, not the detail that you've gone through, but I'd like to point out what I think are the highlights and what are most significant in this um, in these experiments, which are probably the most precise modern experiments that have repeated the MMX. Yeah, and I'm really glad. I'm really sad that I missed the beginning of the presentation. Anyway, let me shut up and listen for a while, and then maybe, as I said, we can go back and
Yeah, and you can
Awesome.
also
some of
review
the
this
highlights.
YouTube stream at any time afterward and check it all out.
Right.
Cool.
Well, excellent.
All
Yeah,
right,
if
so
you
we'll
have any
keep going
thoughts,
here.
feel free at any point down the road or whenever.
Yeah, sure.
All right. All right, so let's see. Where were we at here?
Right after 13.
Just
You
pick,
got it.
yeah, let's pick it up after 13. So the difference in delta T obtained by equation 13 corresponds to the comparison of times of the time parallel and perpendicular to the propagation rays of a single arm of the interferometer in two orthogonal positions, in one of which of the arms is directed along velocity, velocity, and the other orientation is the same as the directed perpendicular to velocity. Really, the construction of the interferometer has two orthogonal arms, L1 and L2, whose rays interfere simultaneously at the screen of the device. The simultaneous occurrence of the interference screen of the two orthogonal rays secures the continual observation of the very fringe and its shift. Delta xm equals delta x naught delta t over lambda relative to itself. How dare you? With this formula for calculating the absolute shift of the fringe relative to itself at 90 degrees at the interferometer looks as follows, but given by equation 14. Formula 14 is written down for the two arms case at length 1 equals length 2 equals the total length. So it corresponds to the experiment of delta xm. A formula given by equation 13 was deduced for a single arm. Simplification of reasoning, it does not include in itself the coefficient 2. Formula 14 reproduces an essential feature of the experimental curve. See figure 1. From this curve and the theoretical model from equation 14, there can be obtained the estimation of the velocity nu of the ether wind. Curve 1 of figure 1 corresponds to the maximal values of the fringe shift observed only at about 1 hour per day and night. Horizontal projections of the ether wind velocity at its ether wind velocity is evaluated from the curve as approximately 480 kilometers a second. In the remaining time of day and night, this projection is lesser than the maximum indicated. 12 hours after the observation of the maximal value, the horizontal projection of the value of the ether wind passes the minimum value, approximately 140 kilometers a second. Thus, during 24 hours period, the observation of the horizontal projection of the ether wind at the latitude of Obelisk changes from 140 kilometers a second to 480 kilometers a second. Counting for that, the term 1 minus n what is it? N into the negative square. Yeah, into the negative 2. Thank you. I was brain farting on that. Equals delta epsilon over epsilon. Determines the relative contribution of the particle carrying light of the light carrying medium into its full permittivity of epsilon equals 1. Plus delta epsilon, and that found by me the effect of changing the sign of the interference fringe shift is observed at the delta epsilon plus or minus equals 1. See figure 1. It can be made up to a notion about the contribution of the fundamental mechanism of the polarization of the light carrying media. Maxwell's formula of the permeativity, epsilon equals 1 plus, or 1 dot plus delta epsilon of the optical media of the of an optical media, the polarization contribution of the factor epsilon ether equals 1, the polarization contribution particles epsilon being less than 0. Since for epsilon being greater than 1, the sign plus delta xm for its positive, and for delta x being less than 1, the sign is minus x delta xm negative. 1 second. Grab some water.
Cool. And you can popcorn back to me at any point if you want, or if anyone else wants to get in on the popcorn line.
The mnemonic for remembering the greater than and less than sig is in terms of verticality. That the one he just read, and for delta epsilon is greater than when the sign is negative delta x of m. You can see that the delta epsilon side is the greater than because the points are very far apart, suggesting a very high vertical. And on the one side, the lines are together, suggesting near zero, as in no vertical at all. So the left side greater than the right side. It's a visual thing you can remember.
Thank you. Oh, did I say the delta epsilon less than 1? I said that backwards.
You got them backwards there. Yeah.
Yeah. Yo, Toby, are you reading?
Oh, sorry. I wasn't sure why. Cool.
Like
Yeah, I
two
can pick up.
ladies at a stoplight. You go. No, you go. No, I insist.
So sign when delta epsilon less than 1 is determined by the dominance of the polarization of ether in the full permittivity, epsilon equaling 1 plus 1 dot plus delta epsilon of the light carrying medium. And when delta epsilon is greater than 1, by the dominance of the polarization of particles of light carrying medium. Insofar as information concerning frequency dispersion properties of the material studied is not well known, I give in Figure 2 frequency dependencies of the dielectric permittivities of water and fused quartz in the region of normal dispersion, squeezed from both sides by the regions of abnormal dielectric dispersion. It presents known from literature and my experimental points of frequency dispersion dependencies on the contribution delta epsilon times mu equaling epsilon mu minus 1 of particles in the fused quartz and water. The influence of losses from the regions of abnormal dielectric dispersion was overcome by such reduction of the length of light carriers down to 10 centimeters, look at table 1, when the possibility remained to register non-zeroth amplitudes delta xm of the harmonic shift of the interference fringe. Subtleties of the skill of these observations are described in citation 7, citation 7. In general, we must take into account the dispersion of the medium, since the respective term suggested by Lorentz enters the full Fresnel formula C prime equaling C ratio to n plus or minus nu times 1 minus 1 over n squared minus lambda over n are taken against the derivative of n with respect to lambda. Is that what I'm seeing there?
I can't help you. Let's see it.
This here. dn over d lambda. So, I can move along here. Values of the kinetic polarization, 1 minus n to the power of -2. So real quick here, let's look at this figure. We have figure 2 here showing frequency dependencies, delta epsilon times nu equals epsilon r times nu minus 1. Of particles contribution delta epsilon and dielectric permittivity, ER equals 1 plus delta epsilon of fused quartz, and that's curve 1. And distilled water, curve 2, measured in the range from infrared to ultraviolet. Ah, okay. 3 is the range of visible part of the observation spectrum. Wow, okay. Hollow circles, O, and solid hearts are my measurements. Shout out hearts. A part of which to the frequency of around 3 times 10 to the 13 hertz was published in the journal Izvestia in the USSR. Inorganic materials, V16 in 1980. Solid circles, red and blue are data from 12 and 13. Points solid blue, heart 1, 2, and 3, and red open circle 4, 5, and 6 were obtained on the Michelson interferometer used as a dielectrometer. Wow, that's a new word for me. Cool. Very interesting.
That looks pretty tight.
All right, so, yeah, it does. It does. I agree. Go back here. Let's see here. Values of kinetic polarization, 1 minus n to the -2, and kinetic. Oh, so we have another chart here actually. So, table 2 shows the comparison of contributions of the terms 1 minus n to the -2 and negative lambda over n, and then n with respect to lambda, or rate, I guess, taken against the derivative of n with respect to lambda of the Fresnel formula for 6 experimental points of figure 1. Okay, so that's how he's getting his curves here. Okay. All right.
Oh, there's my ride.
All right. So back here, values of the kinetic polarization, 1 minus n to the -2, and kinetic dispersion, lambda n, dn over d lambda. Terms of the Fresnel formula for 6 experimental points of figure 1 are given in table 2. From table 2, we see the leading role of the Fresnel term, 1 minus n to the -2, comparing with the kinetic dispersion term, lambda over n, times dn over d lambda. So I'm assuming that's the derivative of n with respect to lambda. The accounting for the dispersion term in equations 7 through 13 gives the correction to the null point of lambda t times delta epsilon, or sorry, delta t times delta epsilon, as delta epsilon equals 1 plus 4 times lambda over n, and then again we have the dn over d lambda. Insofar as that derivative of n with respect to lambda is greater than 0, this shifts. With the account of data from table 1, the null point at 10 to 20% to delta epsilon being less than 1. I have not been able to observe this effect because the experimental errors were too large in order to make such a delicate observation. After publication of Formula 13, it has been deduced by P.C. Morris in citation 14 by another means from a generalization of Maxwell-Sellmeier formula onto moving optical media. This once again emphasizes the indispensable role of the corporeal medium with the polarization contribution delta epsilon in the formation of the law for equation 13. It should be noted that the authors of citation 9 realized as well the necessity to perform the Michelson experiment in optical media. Though the linear model delta xm approximately equal to, or what is that? Doing a ratioed against, what is the tilde with, what does the tilde say?
No, I think you had it. I think it's
Approximately equal to? Okay. I hate when it's just the single one. It throws me off. Though the linear model of delta xm is approximately equal to L delta epsilon, was obtained by them using the eclectic non-Lorentz invariant for effects of the second order by V over C form C over N plus or minus nu, only using the invariant formula of the addition C over N with the relativistic so that was a derivative? Is that what I was saying? What was this?
Which one?
What was this guy here? I forgot what this was.
It's
I think
it's
there's a
relative.
non-relativistic coefficient, wasn't it?
Is that what
No,
that
it was
stood
relativistic.
for?
No,
I'm pretty sure it was relativistic. You're right. I highlighted.
relativistic velocity addition. Relativistic
Yeah, there
velocity
you go.
addition.
Boom. Perfect. Yeah. Operator of a relativistic addition of velocities in the condition C prime being less than or equal to C. The light speed C over N in the optical medium with velocity nu of particles of the medium relative to stationary ether, we obtain the correct formula, number 14, for the shift of the interference fringe when turning the interferometer by 90 degrees. Unnoticed detail capable to reduce and even nullify the shift delta xm of the interference fringe in the Michelson apparatus. We see from the experiment that the sign of the shift of the interference fringe at delta epsilon is greater than 1 is opposite to that at delta epsilon being less than 1. This means that being in the arms of the interferometer, two kinds of optical media will compete with each other. According to Formula 14, which reproduces well this dependence, the effective contribution... are you there, Cassandra?
Yeah, I think so.
Cool. Did you want to say something?
No, you know what happened? I lost the video.
Oh, no.
So,
welcome to Discord.
Yeah. This,
did I...
Are you finished the reading of the second paper?
Nope, we are on page 7.
Okay, let me wait until you finish. I guess you're going to do the two papers?
Yeah, this is the last 2 pages of the second paper, so we're getting fairly close to wrapping up. Probably about another 10 minutes.
Okay.
So yeah, we were on section 3 here. Unnoticed detail capable to reduce and even nullify the shift delta x of the interference fringe in the Michelson apparatus. We see from the experiment that the sign of the shift of the interference fringe at delta epsilon greater... Oh, wait, I already read this part here, right? I think actually, according to Formula 14, which reproduces... Let me just reread this. This means that being in the arms of the interferometer, two kinds of optical media will compete with each other. According to Formula 14, which reproduces well this dependence, the effective contribution successfully of the sections L prime and L prime of prime with respect to delta epsilon prime being less than 1 and delta epsilon prime of prime being greater than 1 will be L prime delta epsilon prime times 1 minus delta epsilon prime plus L prime of prime times delta epsilon prime of prime times negative or 1 minus delta epsilon prime of prime. Firstly, I have confronted with this effect in 1970 when employed in the experiment with air arms the glass phase changer. According to equation 15, at some interrelation of lengths, example given of the gas length prime and gas length double prime sections, the phase shift of equation 14 may be vanishing. Two important practical conclusions follow from this experimental observation. 1. The plates with delta epsilon being greater than 1 should not be used as phase changers in glass-filled interferometers if the optical medium is a gas or water, since for the glass delta epsilon double prime, 1 minus delta epsilon double prime, is approximately -2, while for the air, delta epsilon prime times 1 minus delta epsilon prime is approximately plus 0.0006. An invisible range is an invisible range of light. Wavelength water has delta epsilon prime 1 minus delta epsilon prime, approximately equaling plus 0.09 divided by plus 0.24. So I use instead a water triplex plate comprised of the water layer of thickness of approximately 1 millimeter, located between two glass plates, each of the thickness of around 0.1 millimeter. The effective value, delta epsilon double prime times 1 minus delta epsilon double prime of such triplex is about plus 0.15, an example of the same size as delta epsilon prime times 1 minus delta epsilon prime, equaling approximately 0.0006 of the air. 2. In order to increase the effective length of the arms, there are frequently used configurations with a zigzag path of light. Such construction demands the involving of many mirrors. Disposing the mirrors, such as it is customary in ordinary life, by the glass side facing to the incident light, we come to the parasitic effect above mentioned. Opposite signs of the delta epsilon times 1 minus delta epsilon in the air and glass compensate each other. As being evaluated by Formula 15, that I firstly found experimentally in citation 3, the thickness of glass layer 0.3 millimeters cancels the phase difference produced by 1 meter of air path. Thus, for the interferometer with length equaling 11 meters, the zigzag reflecting mirrors of such thickness are capable to reduce 3 times the shift of the interference fringe. Wow. For the thickness of 0.5 millimeters of glass directed towards the incident light, the shift of interference fringe will be nullified. In order to remove this harmful effect, the glass mirrors should be oriented by the backside towards the light. In this event, the amalgam layer should be thoroughly polished. No wonder if there will come out dozens of similar interferometers in the world where the 0th shift of interference fringe occurred because of the improper using the glass mirrors. Experiments performed on such interferometers contributed their portion of mischief into the myth about the negative result of measuring the absolute motion. My experiments in citations 3 and 4 debunk these myths. So, finally, discussion of results and conclusion. Section 4. On the Michelson type interferometer, there was obtained for optical media with a refractive index greater than n of 1, or n being greater than 1, the shift of the interference fringe that enhances considerably the ratio of signal to noise. The positiveness, rather than the negativeness, of Michelson experiments is thus demonstrated. There was measured the difference of round-trip times between the paths of propagation of light in parallel and transverse direction to translatory motion of the interferometer. It was found that this difference depends parabolically on the contribution delta epsilon of the particle's polarization into the full permittivity of the optical medium. Experimental observations are well described by the theoretical model based on the pre-relativistic, appeared to be Lorentz invariant, and non-Galilean formula of Fresnel for the drag of light by the moving optical medium. Thus, there was shown the inadequacy of the additive rule c plus v for composition of the light speed c and the velocity mu of a moving inertial body used by Michelson in deriving Formula 3. It should be stressed that in terms of the interpretation suggested, which is conceptually different from the standard one, all known measurements, example given in citations 2 and 10, on the Michelson-type interferometer, where the normal air pressure was maintained, that corresponds to delta epsilon equaling about 0.0006, always would indicate delta xm not equaling 0, and hence delta t not equaling 0. That is why all experimenters reported that in experiments with normal air pressure, they noticed non-zeroth values, delta xm, among the noise. But Michelson missed delta epsilon in his Formula 3, and thus, by the noticed trace of delta xm in the light carriers, he obtained an underestimation of delta epsilon to the power of -1/2, being approximately 0.0006 to the -1/2, equaling 40 times of the absolute speed of the Earth. And so all mentioned authors obtained instead of 200 minus 400 kilometer per second estimations, lying within the bounds of the noise, 5 to 10 kilometers per second. I took into account delta epsilon in my Formula 13, that saved from the fatal mistake, which omits the ether wind and enabled me to detect the motion of the Earth with respect to the stationary ether. The projection of the absolute velocity of the Earth on the horizontal plane of the experimental setup, calculated from equation 13, appeared to be in various times of day and night at the latitude of Abinsk 140 to 480 kilometers per second. Comparing equations 3 and 13, we see that accounting for delta epsilon gives 1 over delta epsilon air, being approximately 40 times greater velocities of ether wind than Michelson-Morley, citation 2, Miller, citation 10, and others obtained from equation 3. The watching of the discussion caused by the publication in my paper in PLA citation 4 shows that many, if not all, have forgotten that the first 40 years after 1881 experiments of Michelson regarded negative because of that seeking to measure delta xm experimenters was not able to notice a weak harmonic shift, delta xm, of the fringe shift among the background noise, see citation 7, in following 40 years, from 1920 to 1950, that's 30 years, when owing to experiments of Miller, citation 10, the fringe shift has been confidently observed, the fatal role and attribution of the experiments of the Michelson type to negative was played by 40 times understating the error in Michelson's formula of equation 3. In comparison with the correct formula, citation 13, rightly accounting for the dielectric permittivity of the light carriers of the interferometer. The disregard of the inertial contribution, delta epsilon, by Michelson and all who copied him was the reason...
How many of those?
Yeah. The disregard of the initial contribution delta epsilon by Michelson and all who copied him was the reason why famous experimenters on vacuum interferometers and experiments with gamma rays, thank you. Gamma rays gave the negative results. Supposedly, before my experiments, a medium, example the air, was considered an obstacle for the measurements, whose elimination allegedly would retain the shift of the interference fringe in pure form. This led to what the expectations by the formula of equation 3 of the value of shift in vacuum were overstated about 1,600 times, comparing with that could be observed in the air in citation 7. At the same time in vacuum, n equaling 1, as I've shown for the first time experimentally in citation 3, the shift is absent since delta epsilon equals 0. And since the corporeal medium is real environment, is an equal participant in the process of forming the interference fringe shift, it is clear that the vacuumization of the light-carrying parts of the interferometer vacuum did not confirm the results of the Michelson-Morley, citation 2, and Miller, citation 10, obtained in the normal air pressure. In all such experiments, there was delta epsilon equals 0, either because of the vacuum being part of the interferometer where the light goes, or due to vanishing delta epsilon gamma. Since the dielectric permittivity epsilon gamma of any optical media in gamma rays, i.e. delta epsilon gamma equals epsilon gamma minus 1, equaling approximately 1, and I demonstrated by the direct experiments that when the air is evacuated from the regions where the light propagates, the harmonic shift of the interference shift vanishes, become 0. Indeed, by equation 13, delta epsilon trending towards 0 entails, heading towards 0 entails delta t heading towards 0, since delta xm is approximately delta t. The experimental results obtained by me in their theoretical interpretation bespeaks of the conventional character of the special relativity theory conditioned by the artificial extrapolation arisen by chance in 1881 because of the anti-relativistic state of science. Of the additive rule of composition of velocities of inertial bodies to electromagnetic waves emitted by the inertial source. It is strange that Formula 3, obtained by Michelson on the basis of the classical rule of addition of velocities, C prime equals C plus V, is not until now publicly acknowledged as a harsh error of the epoch of 1881 to 1905 years. And yet in the form C prime equals C plus V and Formula 3 is not valid for the rotary interferometer, with transverse light-carrying arms also, because they do not take into account the great sensibility of the measured by the interferometer parameter delta t, i.e. the difference of times of propagation in the longitudinal and transverse beams, to refractive index of refractive index n being greater than 1 of light carriers, and this is an irrefutable experimental fact. After all, this device has not simply the dependence of delta t or delta xm on the refractive index n of light-carrying media of its arms. It exhibits the supersensibility of measurements delta t or delta xm to variations of the refractive index var n of the optical media of each arm already in 4 to 8 signs, or 4 divided by 8 signs, after the point var xyz n equals 1 xyz. So, to go on regarding the experiments of Michelson type negative in principle, the period 1930 to 2010 years, when there have appeared convincing proofs of their quote-unquote positiveness in the sense of delta xm not equaling 0, citations 2, 10, 3 through 8, is the misfortune of the epoch. As a matter of fact, the special relativity appeared to be the artifact of this adversity. All the corpus of already published by me experimental results convincingly demonstrates that Michelson-type experiments are positive in principle, since they register the Earth's laboratories delta xm not equaling 0. Moreover, they are confidently revealed on the basis that, or another fixing delta xm not equals 0, the absolute motion of the Earth in the stationary ether with the value of horizontal projection of the velocity from 140 to 480 kilometers per second, registered in 24-hour cycle of observation in the day and night at the latitude of Abinsk. After all, in the orientation of the longitudinal arm of the interferometer to the Hercules constellation, the Michelson-type interferometer, by any non-zeroth measurements, delta xm not equaling 0, processed with my formula of equation 13, confidently state at any time of day and night and at any point of location the Earth's laboratory, the velocity of the Earth relative to ether about 600 kilometers per second. Citation 3. So yeah, there we go. Interesting. So I tracked for a lot of that. He kind of lost me when he jumped to his velocities, honestly. Like everything made sense to me about the first order stuff, and with like refractive indices and how we're not actually in vacua with a lot of the earlier stuff. And so that's why we actually get readings. But then I'm like a little bit confused how he gets to 600 kilometers per second.
Let's see. The interpretation of his wavelength amplitude, of his light amplitudes, the way they fluctuate, as one of the charts showed, in a 24-hour cycle, for the location of northern latitude, Oblinsk. The deviation in the go up even further. Yep. Keep going. It's where it shows the time variation. Graph that shows the time variation.
You know, I think we want to pull up the other paper, actually. I think it was in there. I think there was a time graph. Because in this one, that's this whole paper. We have the wavelengths. Formula.
Variation with index of refraction. Yeah. Keep going.
There's this one.
That's an Yeah, that's interesting. It shows that the index of refraction is 1, not just when you have a vacuum, but when the value of delta E, delta epsilon, is equal to 1. And that turns out to be the square root of 2. So that's, you see that graph that shows at the beginning, delta epsilon increases, which is what you expect. As the index of refraction increases, the amplitude that you detect increases, right? Then, unexpectedly, it levels off, and then it actually comes down again and crosses at 1 equals 0. When delta epsilon equals 1, I think n squared equals 2. That means n itself equals square root of 2. So this, to my knowledge, has never been discussed by mainstream science. When the index of refraction reaches the square root of 2, you get the same result as if you were in vacuum. That is when n equals 1. And he proved this with at least 2 or more different indices of refraction. You see water, quartz, flint glass. Those are all different index of refractions, but they all obey that law. When they cross the delta epsilon line, where they equal 1, well, rather, they all equal 1 when they cross that line. Of course, they all go to 0. Delta E equals 0 represents when n equals 1, which is vacuum. That's not the chart, though. If you keep going up, Toby, we can get the dependence on time. No, somehow we missed it. I know it's in there. I saw it. Oh,
Yeah, it's in the first paper, it looks like.
All right,
There's
let
a
me pull that one
couple
up real quick.
time-dependent ones. Let's take a gander at that.
Yeah.
That's it.
Cool.
Okay, so what are we plotting? We're plotting the amplitude, A, of the electromagnetic wave, the light that's being tested. And we're testing it over from 12 a.m. to, well, he's using
That's
a
noon to
24-hour
midnight
clock.
to noon. Yeah.
Yeah, this is a 24-hour cycle, and you'll notice that the wave fluctuates from peak at 12, which is really arbitrary. It depends where you're located. Then it basically declines until it reaches a minimum at about 24, which is 12 hours later. And 12 hours after that, it goes back to a maximum. So this cycle is exactly sidereal time, which means it's not a cycle caused by the sun, because it would be 4 minutes difference. So if you test this accurately, you find out that this is a stellar day, not a solar day. It means that the source of this wave fluctuation is coming from space, coming from the sky. Now, what I could do is connect this with the Hildegard presentation and remind you that model there was ether winds being generated at the edge of the universe and eventually being focused on the Earth, solar system in general, but specifically the Earth. And that variation shows that as the sources in the sky rotate every stellar day, the effect that we see on Earth is a variation in that ether wind from the peak that you see at 12 on the left to the peak that you see at the 12 on the right. So this is an experimental proof that the ether wind is reasonably the cause of the variation that you see in this graph. Because if the ether wind changes, then the speed of light changes, and if the speed of light changes, then the interferometer pattern also changes, and it changes in the way that you see in this figure too. So this is one of the things that I would drag out as a proof that there is an ether wind focused on the Earth. It has a variation corresponding to the location of a source in the sky. And that's what I would use as an experimental proof of the validity of the Hildegard model. Any questions?
Oh, excellent breakdown.
Yeah, I can definitely see how you can draw that connection. Yeah.
Okay, so you see the interferometer tells us if there's a variation in the speed of light, but the speed of light can vary because of a change in the speed of ether, because from the Sagnac experiment, we know that the speed of light is not just c, it's c plus v, where v is the speed of ether. So if the v varies, as you see in this graph, then the interference pattern will also vary.
Yeah.
And so this destroys, of course, the claim of the mainstream that the Michelson-Morley experiment showed that there was no ether because it was a null experiment. They didn't detect anything. And of course, that's a fabrication. What they actually found was an average of about, 5 kilometers per second. They only did the measurements over 6 weeks. They only did 5 sets of measurements. Dayton Miller and V.V.Demjanov, they did thousands of experiments. And they did it with, in this case, with the most precise interferometers that are available. These experiments were done in the early 1960s, which is what, 80 years after Michelson Morley did theirs. All right, so we look at the rest of the, why don't you start at the top, and then I can see if there's anything interesting. Let's see.
Yeah, this one was pretty short. This was only 4 pages.
Yeah, well, notice that mainstream ignores all of these. You won't find these. In fact, Demjanov, he had one paper that he submitted to Physics Review Letters that was retracted. And that's because he was in conflict with the mainstream dogma that the Michelson-Morley experiment showed that there was no ether. Let's see if there's anything.
Yeah,
All right, he saw. Go ahead.
I was gonna say that was the first time I'd ever seen that when I had imported his papers to my Zotero thing. It had a little disclaimer with it. It was like, this has been officially redacted or whatever. And I was like, what does that mean?
Yep.
And yeah, that's crazy, dude, because this is direct contradiction to it. I mean, we're looking at the measurements and they're going, guys, there's no measurements. You boy, like, I mean, yo, what's up, Miller? Like, it's your boy. Like, hey, Gallo, the boys are in there.
Yeah.
They probably made all the same mistakes in the millionths, and that's why they kept having the same errors all the time.
Just that same systematic error,
right?
Just for
What it
context,
means
I did
is
some. Sorry, man. I did some geography just for context a second ago, checking back to 1971 and what was the moon doing relative to the sun, and it's just past a new moon on that day. Yeah, exactly. So when you're looking at that curve, I think part of why we're seeing some enhanced slope towards the maximum, as in when noon is happening, I think the moon may be a little more involved towards noon.
Oh, dude, is it going to be another case where it's the fluctuations are going to be dependent on the moon being parallel and perpendicular to the sun?
Well, I want to get close, and they're like,
think
"Oh,
so.
it's
Just how the curve is affected. Maybe not the total maximum values, but just how you get there. I think there could be some topographical
For sure.
influence to
Talking
that
about
curve.
the kind of the point to it here.
The slopes on the way to and from, that they're steeper at the time of a new moon because of their co-proximity at noon.
right."
Yes, I totally agree that there's going to be the moon ether wind. And if you carried this experiment out for 366 more days, in other words, a whole year, you would find, like Dayton Miller did, if you go back to his experiment, you'll see that he found that the amplitude fluctuated over one cycle over a year. What could that possibly correspond to?
Solar
But we
wind.
know that this, excuse me?
I was gonna guess and say solar wind because it have solar ether wind, lunar ether wind, or something.
Well, if it's 366 days, then it's got something to do with the annual rotation or elevation of the Earth, the sun, in its seasonal north-south motion. Remember, the sun doesn't just rotate around the Earth every 24 hours. It also, in a degree or less each day, travels north or south. And that slight change can be detected over a yearly cycle. So if you go back to Dayton Miller, Janov doesn't do a yearly collection of data, but Miller did. If you go back to that paper, you'll see that he detected the wind that drives the sun north and south, that creates the seasons. And that, of course, will not be obvious in this daily cycle. But if you go back to that paper and look at it, you'll see the yearly cycle. And that corresponds to another ether wind that moves not just the sun, but the whole solar system, north and south, in a range of what, 26 degrees plus or minus, north or south of the equator. And yes, the moon cycle might be those variations that we see in that 24-hour cycle. We see slight variations up and down. And those are the three principal ether winds that affect the Earth. One that drives the sun, the one that drives the moon, and, well, there's two that drive the sun. One that drives it in its daily motion, and the other one that drives it in its north-south direction. So if you start putting the different experiments together, you get a lot of proof, a lot of evidence that there is an ether wind, and you can predict what it will do based on experiments that have already been done. But if you're mainstream, you ignore it, or you force experiments that prove it to be retracted. Anyone there?
So,
Yeah,
yeah,
we're here.
and,
That was
and null,
just
null
thinking it
would be
over.
the thing they're trying to induce. And that you're right, to more fully embrace the data over longer time samples and many more samples, you can start to develop time-dependent contours of the ether force.
Yeah, so if you go back to Peyton Miller, you can check what I said. There's two cycles that he saw, a daily cycle, which is the same as Demjanov saw, and a yearly cycle, which requires more data, obviously, but that also is evident in his experiments. Okay, you want to look?
Have you heard
You want to
of?
look at?
Have you, I was
To
gonna
look
say,
at
have you heard of
anything more?
Hector Monera? He did. He measured the same periodicity that Miller measured as well.
Right. I would say that the key figures since Michelson Morley are Dayton Miller. Those are key experiments. Analysis by Maurice Allais, okay, who won the Nobel Prize, not for physics, but for economics, but that's because of his deep mathematical knowledge of statistics. In other words, he was an expert at interpreting all of these graphs that you see, the daily measurements of ether. And who else? Demjanov, right? He would be the latest. And all of the names I mentioned support ether wind. If only they got more publicity, if they appeared in textbooks, and if they weren't retracted by the mainstream publishers like Physics Letters.
Damn.
Yeah, you may have to search for that graph. What you could do, you could go to
Oh, we got yo, Toby, will you click that graph that Stone made? Just pull that up on screen.
Sure, yeah. And
Oh,
then this
too.
is Maurice Allais' analysis. I know he has some decent charts of it, but I can take a look at what Stone posted here.
yeah, these are daily though.
Oh yeah, here's the one.
Oh,
For
the
Stone.
Demio paper has the annual periodicity measurements. Let's see if I can pull it up for you.
I think Galev goes over it as well. At one point, I want to say in the 2001 paper.
Yeah, here we go. It's in the live chat as well.
Oh yeah, there's a good one.
Maybe a Google search for Peyton Miller, and then go to images. And you would just get the images of the papers.
Oh, so here's some here. We've got February, April, August, September.
Yeah, you got to see the chart though to see the fluctuation year by year.
Oh, I thought he had charts, but I guess not.
Oh, I think you flew past one.
Well, I think they were all daily. These are daily, I believe. Hour by hour values.
Yeah.
Now, still, it's an interesting comparison. September, August. But yeah, there's no. I thought he would have had a yearly, annual chart, but it does not appear that he does. At least not in this particular book.
Yeah, there's a French publication where he definitely does. I don't have that off the top of my head.
But yeah, the DeMeo ones are pretty good. Oh, there are more as well.
All right, let me try Google search for Peyton Miller images.
Yeah, that'll be interesting to see if you get any results from Google.
Last picture. God. All right, I get the hourly. All right, he's got seasonal displacement. I don't know how I can get this figure to you.
If you're able to copy paste the link, you can put it in the main chat. There's a text channel. Copy paste it in there.
Okay. Now, I may get lost as I'm moving around, but I'm going to try and get back.
The simplest way is just to right-click the image and hit copy or copy image, and then come to here to the chat and just hit paste, and it'll slam it right in there for you. Paste and enter.
But
Which source is it in? Because we might even already have
let's
it.
see. Yeah, it looks like Alan has it, right? In main chat.
Is it from the DeMeo paper?
No, Maybe. I don't know. I just searched for images. In the lower left, on the one that's in main chat, you see seasonal displacement. And you see the daily fluctuations on top of the yearly.
Oh yeah, the DeMayo stuff. Yep. Seasonal displacement. That's So that's from DeMayo 2014. Does a cosmic ether exist? That was his analysis.
Now you see that there's certain seasons where the fluctuations are high, and the others where it's low. Predict that those high variations occur where the sun's motion is changing fastest, which is the equinoxes. So every 6 months approximately, you would have higher fluctuations because of the sun is traveling at a faster speed when it crosses the equator. The slowest speed, of course, is when it approaches the plus or minus 23 degrees.
Yeah.
It says that measurements latitude dependent, analyzed with attention to Earth's rotation, axial tilt, movement around the sun, and the sun's movement through space, revealed through a common sidereal cosmological axis of ether drift.
What are you quoting there, Shane?
This is from a compilation of his work from Orgone Lab, that website. I pulled, I think, all the graphs, and they have a compilation and just like a comprehensive summary sort of thing.
So I mean, to assert that it would have anything to do with the rotation of the Earth is pretty wild.
Dude, so was that Miller noting that, or what?
I think that was DeMayo saying that, I think, right?
I think even Demjanov said that. He still thinks that this is the rotation of the Earth.
Right, because I think, yeah.
But again, it's relative. Is it the Earth that's rotating at 24 hours relative to the stars, or the stars that are rotating at 24 hours relative to the Earth? You can't tell because that's a kinematic measurement. You can only tell that by dynamics.
Nope. Oh, it says
because of Newton's bucket, we have concluded that the Earth is the only reference frame you can use in dynamics.
It says figure 2. So that periodicity one, periodicity of the global ether drift from Dayton Mills Mount Wilson, says 1925-26. The top graph, 4 separate months or epochs measured at different times of the year, organized by sidereal time, showing a definite periodic curve. The heavy line is the mean of all 4 epochs, and the bottom line is the same data organized by civil clock time coordinates. Yada yada yada. So it's like says that these data curves are organized along azimuthal, which later always correlated with the sun's position. Look at that. So do we know if Dayton Miller thought he was measuring ether drift, or well, no, he thought that ether drift was affected by Earth's rotation, I think is how to best put that.
Yeah, I mean, I that is what he writes, and that is what he modeled out, and a couple times in his papers and stuff. But I have a theory that he was just would he not just do that possibly just to be published? I feel like
right. Like, how do you get published and not say that? Yeah, that's a good point.
He's like, I distinctly remember in that one paper, doesn't he pretty much just say that he can't explain why the velocities don't match heliocentrism, but he accepts them as is in the first order? Like he doesn't prescribe a mechanism to why on Earth it's not at those speeds. He assumed that he was measuring the velocity of the Earth around the sun based off of the min-max fluctuations, right?
Yeah, an inverted reference frame of heliocentrism, looking at the sun and being like, well, It's actually rocketing backwards. I'm rocketing backwards. It's thing still. That's why it looks like it's setting it. From that perspective, yeah, maybe.
So yeah, he did say that, he did model that, but you know what his actual position was, I kind of think it's kind of up in the air, personally.
Well, you know the story of Shanklin, right? The one who was Einstein's buddy.
Yeah.
And
You talking about the
after-
assassin?
exactly, the science assassin. He was Einstein's buddy, and after Miller died, so how can you defend yourself after you're dead? He attacked Miller for having no experimental savvy, that he didn't take into account thermal effects
Temperature brought down
on the
by temperature.
and that's exactly what Miller was very careful.
Exactly. That's why it's so funny.
Mhm.
He took he was very careful when he went to Mount Wilson, because he changed from a warmer climate in Cleveland to a colder climate on Mount Wilson. He compensated with heaters in order to keep the whole experiment at the same temperature, isothermal conditions. And he was attacked because he had thermal problems.
Yeah.
I believe he also tracked pressure.
Not while he was alive, right? When he
Yeah.
was alive, no one said boo. They were like, But when he was dead, oh, look at all the problems. Oh, you know what? Inaccuracies came about.
14 years after he died, too, right? Like, not even.
That's how you know you have a good argument. You wait till the dude's dead 14 years, then you make it publicly.
Mhm.
Like, now that everyone's forgot about it and moved on, I'll just, like, dig it up real quick.
Can I just contextualize history for you and everyone else?
Yeah. Redefine history, and then we'll move on from there.
Part.
Oh, yeah, Einstein, tell me again how you came up with Lorentz contracting without citing Lorentz. That's very cool. Oh, you came up with that whole theory by yourself, dude. Nice, dude.
It's called Lorentz
Dope.
contraction. Wait.
Oh, yeah. Oh, a new theory that's based on Lorentz symmetry, but you never heard of Lorentz? Oh, wow. It's so interesting, Ein. Tell me more.
Big Al.
You know, well, Maxwell was pretty brilliant and stuff, but he just didn't quite get it like Einstein got it. That's why Einstein had to fix his equations.
Sometimes you're just a big dum-dum, and then, like, you know, someone with a much bigger brain comes along and just swoops up your equations for you.
Because takes all your stuff for you. You're too dumb to know what to do with them. Yeah,
you're just mentally inadequate, stumbling around the chalkboard.
When you invent your equation but don't know what to do with them, in comes Einstein.
Dude. Hey, did your hand-derived equations not comport with an assumed velocity of 30 kilometers a second? Hold on a second. Einstein will fix you up.
Did that pesky Earth not move? We'll negate some relativity for you. Invert that word right around you. Yeah, I can sell that. The coordinate systems are important, man. It even says in this one, it's like it demonstrates that the detected axis and periodicity of ether drift is the same for different times of year, but this can only be seen when the data is viewed within a sidereal coordinate system. Right. I imagine it would show the same within the elliptical coordinate system with the sun, same way with the sporadic meteorology data. That elliptical system, I feel like if they plotted it there, it probably would coincide nicely since that's already coincided with the solar periodicity.
So yeah, those Demjanov papers were good reads, and credit to Stone for shooting me one of those, like, I want to say like 7-8 months ago. We've skimmed them all. I know I've definitely taken a look at them, but they definitely deserved a good, solid, full reading. here live on the channel, and definitely appreciate the discussion as well.
He's
Anyone
a
else?
top-notch experimenter, and it's a shame that all of this research is not making itself into the public view, because I mean, this is all supporting Aether, and supporting a fixed Earth. And maybe I should note that I want to finish the Hildegard round 2, and I'm going to be on the beach in August. So if we can get that in before August 1st on a round table or something, I
Absolutely.
think it's just about just about ready to go on to be shown.
Excellent. Yeah, absolutely. And maybe we can squeeze in a quick Hildegard reading night before then as well. But yeah, that would be fantastic. Whenever works for you, honestly. Well, we can accommodate.
23rd.
Literally, just pick a day.
Or any day. Yeah.
Yep, exactly.
Well, basically any day for me next week.
You want to do next Tuesday?
Yeah, that's good.
23rd.
Perfect.
Next Tuesday, the 23rd at 8 p.m. we can shoot for, and then you can tell us if that works for you later this week.
Sure.
Cool.
Oh, good.
Excellent. Well, then you heard it here first, y'all. Next week we may have part 2 of Hildegard. Awesome. And then tomorrow night, Alan, you're doing a presentation, right?
Bruhif is going to be presenting tomorrow on the 16 flight books that recommend the Earth's flat or whatever.
Oh.
So there was some massive inaccuracies with that book presented by Flat Earth Banjo, and Bruhif's going to go ahead and correct that because we'd rather have people use arguments that are that aren't going to make you look bad if somebody knows how to use a map. So,
okay. Well,
yeah, he's going to be presenting that, and then after the 23rd, I'll be doing a presentation on GPS / the Sagnac effect,
okay,
and relative simultaneity.
Okay, so we'll get that schedule straight, and we'll let y'all know. But definitely be looking forward to all that. Especially next week. Really looking forward to hearing more on Hildegard. And yeah, so I guess we can wrap things up here unless anyone has any final thoughts.
Yeah, I have a final thought. There's no ether wind velocity, and the Earth is in motion. Copernicus was right, and that's it.
Okay, take care, everyone.
Fictitious forces define all of physics, and the Earth's only an inertial frame when we need it to be, and the sky's in motion.
Yeah.
There is some motion because the sky's in motion because of the Earth is in motion.
And I choose to believe, and you can't stop me.
There we go.
We'll give you a mainstream medal.
As Shane likes to say, for a good laugh, we've resorted to steel manning mainstream positions on physics and cosmology. Cosmography, if you will.
It's our comedy night. We try to just best represent their beliefs as best we can, and we can't stop laughing. So.
Well, cool.
Alan, I want to ask, what did it for you, though? Did you see a sunset and then you were just like, oh, it's got to be a globe?
Yeah.
Is that it? The sunset? It gets them every time.
I saw sunset and I was like, oh, there is no ether wind. Man, I was doubting it. Like, you know what? I knew it.
Like, if there's an ether wind, how would my car start, you fucking idiot?
Dude, if there was an ether wind, explain this loop-de-loop 3-decker roller. Okay?
Dude, if there's an ether wind, explain this Lego set that I put together. It's very complex. It took a long time, and I accomplished it in a modest time for an adult.
People on the internet, man. Whew.
If there was an ether wind, how would I be able to hold my toothbrush when I brushed my teeth? Wouldn't it go flying out of my hand?
Dude, someone really said if there's an ether wind, how come it doesn't push all the planes off course?
Respect.
Yeah, well,
Well, they want to cite Coriolis when it's convenient, don't they? But
funny, the dude named
Yeah, dude, a
Coriolis said that.
fucking Coriolis will never throw a plane off track, dude. But an ether wind, dude, I'm gonna need to see those dynamics. What's your viscosity? How much is it affecting it? If you shoot a bullet, are snipers accounting for ether wind velocity? What's your ether wind velocity relative to your latitude?
yeah, how are you even?
Did
How
you
are you
use an
even for
eclipse
counting?
to measure that?
Yeah, even accounting for tubular versus laminar fluid dynamics. Like, come on, man. Like, we need to see your Reynolds number, and we need to see everything. All of a sudden.
Well, cool. That was fun. That was good.
Yeah, I'm gonna go ahead and